Yes, hello. I will just wait a second for my slides to come up. Yeah, you have already heard about Utu quickly this morning from our CEO Jason, who was on the panel earlier. And I want to get a bit more technical in my presentation about what we are actually doing in terms of trusted recommendations at Utu. So I would like to start with a bit of history because our company is easier explained by starting historically where we came to Kenya, or Jason came to Kenya, and as you mentioned earlier, saw that there's a problem with transport and technology for transport, and then decided to start with the taxi app to find out soon that there's actually a trust problem in this sector here, where people, or many people, don't just like to get into the car with just any driver, but they would actually like to know who it is. And if they can't find their own known drivers, then maybe they would ask friends to do so. So what we did was develop the app a bit differently from Uber and the likes, and instead focus on the drivers themselves and actually give the client the choice. So like in this screenshot, which I took just yesterday, it shows that you can find your own favorite drivers, or you can find Facebook friends' favorite drivers. That one last there with a little Facebook icon, for example. So that's how we started. And then in the beginning, we were a bit skeptical of how that model would actually work and if people would actually be connected well enough to each other to come up with a useful number of recommendations. And we were quite surprised positively by how quickly the social graph built up in our app. So basically we asked people to connect with Facebook, meaning log in with Facebook, which gives us the Facebook friends, but also on the Android app to give us access to the phone book, which you don't have to do, but you can. And then we see who of your contacts is already in our system, and we offer to connect you to them in the app, basically. And in the future, we are going to offer more connection possibilities. And that sort of big blob there on the right is basically a screenshot of the social graph as it was last year at some time. The yellow spots are mostly users. The gray ones, I don't know if it's visible, are drivers. And then all that black stuff is basically connections. So there's more than 100,000 connections in that graph between people, and that's only in Nairobi. So yesterday I talked to some people who were intrigued by Tesfa's presentation and that he actually showed some code, and I was asked to also show some code. So that's one of the queries we use to find out who's connected, maybe indirectly, with a maximum number of in-between hops to some driver who was then favorited by that last one. But for the not so technical people, so the lower section here shows the result of that for one example, and it shows that, okay, we have the requesting client on the left and the offered driver on the right, and then there's many possible paths between them. So now if we want to show some recommendation, we can clearly not show all of this because there would be, I don't know, many screen pages to read. So we actually need to make a choice whose recommendation we show. And to do that, we look at some stuff like, for example, the connectivity between clients themselves. So similar to that query, there's a very similar query where we look at connections between clients, and then we apply some weighted sums to basically get a measure of how well people are connected. And then we, having that, thought, okay, does that tell us actually more? So do people who know each other very well and are very well connected via common friends and so on actually exhibit some similar behavior? And one thing that we looked at is, for example, comparing the degree of connectivity to the difference in rating behavior of drivers. And I mean, this is not enough data here because we analyzed only a subset, and of course each of these points represents basically a pair of clients who rated the same driver in some of the similar circumstances, and then also requiring a minimum number of such ratings to exist. So we are still in the process of building more data, but you can already see that actually the better the connectivity, the less the difference in rating seems to be. And that's quite an interesting and encouraging result for us. Some more code for Lisbeth particularly, or other techies here. So if you translate that previous slide into actually making a choice which recommendations to show here in functional style JavaScript, then it looks a bit like that. Okay, then some results that are more like speaking to the outside world. I stole this slide from our pitch deck. You will see it maybe later again from Jason. And we see actually, okay, 96% of people have chosen a socially referred driver over other drivers. We get 20% better conversion for rides where we can show recommended drivers as opposed to other rides where we can't. And we also get better ratings for the preferred drivers this way. Then we have some more results which are not on the pitch deck and maybe a bit more scientific, which is why they don't look so pretty, but I just wrote them down there. Basically, comparing rides where we show a direct favorite as opposed to alternative drivers who are actually closer, meaning they have a smaller ETA. We get, and in 52% of the cases, people would actually choose a farther driver that, however, is a direct favorite. And then if we consider not direct favorite, but social favorites, as we say, okay, your friend likes this driver instead of yourself, then we still get 35% of rides which are chosen even though there are other closer drivers. So our intuition here is also confirmed by some studies, like a Nielsen study, saying, okay, 92% of people actually trust recommendations from friends and family above all other forms of advertisement. So, so that's what we are basically building on here, and that leads us to Utu now. So all of that kind of grew up in the taxi app, but Utu now takes this basic recommendation model, which was first only baked into the taxi app, and breaks it out into its own product to basically offer to other platforms these sort of recommendations, like find a trusted programmer, car repair service, hairdresser. One of our first pilot clients is a peer-to-peer lending platform targeting mostly farmers via farmer associations. And to do that, we offer a API for our trusted service. And the main function, the first there maybe is, okay, you want to get some recommended providers, basically. And for that, you provide some criteria of the client that is actually doing the request, then what are they actually requesting. The context, so for example, in a taxi ride, it might make a difference if you are on a business trip, you might want a comfortable car where you can work with your laptop and a driver that doesn't take only all the bumps or whatever. If you're going to a party, then maybe you want a car that is fancy and has nice music, stuff like that. And then for other domains, there's maybe more serious context parameters, like for example, in that peer-to-peer lending platform for the farmers, it plays a role. What are they actually trying to take a loan for? What crop do they want to grow? What's the schedule of investing, like fertilizers or that? What's the expected return of investment, the schedule, and the risk? So all of these should be somehow recognized by our system and managed appropriately when giving recommendations. And to do that, we obviously need a lot of data, so we provide some data consuming services where hopefully we get enough data from the platforms that are our clients, which in the existing pilot clients is the case. But I'm also going to talk a bit more about getting data in a moment. Right now, let's just assume we have all that data. So we have a request, we have our social graph database, which also has some amended data, like including previous experiences, and then we have some traditional databases and maybe machine learned models on top of that. So how do we get to the recommendations like I showed earlier, or in text form? They could be like, okay, your friend so-and-so likes this driver because he has a secure driving style and he's always on time. And we know from your context that this is right now particularly important for you, which is not written there, but kind of implied. And now we could take the sort of, how do you say, well, the plain machine learning approach, do some pre-processing, and then take one of the fancy things that are out there, like collaborative filtering, which has been traditionally used for recommendation systems, or any form of neural networks, or something like Markov decision processes. But all of these methods basically require to have huge amounts of data up front. And there are some of the big companies that are always cited here, like Facebook, who have that data. But we, as a starting out startup, we have some data. Okay, we have that social graph, for example, which we hope to be able to also use across use cases. And from that peer-to-peer lending platform, we're actually getting historical data of millions of farmers. However, we are probably not getting enough data to make that step just like that. So what we are actually doing is we are decomposing it into simpler steps, trying to identify the relevant class of services given the context, trying to identify clients who recommended those services in the past and which are somehow similar, where similar is defined by the concrete use case, basically. Then determine something called the comprehensive trust, which means, okay, what's the trust of this person in, to this other person in respect to the service type that is requested and the concrete circumstances. So basically, who trusts whom for what, in what situation. And then we construct some kind of logical representations of the possible recommendations that come out of that, which we then need to basically reduce and choose sort of the best one, where the best one, again, is determined by some machine learning component that we are basically still researching, and then finally constructing those kind of sentences or constructing those kind of graphics that we showed earlier. Concrete methods that we are looking into, there has been quite a lot of research in the last few recent years. This is just 2 examples of papers that are particularly relevant to our case. Don't really want to go into the details here, but if you're interested, look them up. We use some public data sets also to test and verify our approaches, like opinions, for example. But it's sort of limited use because they have a very simplified trust model. And in our case, really, we're trying to combine a lot of things that have not been done in that form previously. So concrete technologies. We have the fancy stuff, I would say, that we use for all the machine learning and the graph analytics. And then we have some old school stuff as well, classical databases. The external API is simply implemented in Node.js, which would then call out to our machine learning models running in Python and stuff. And hosting is done on Node Africa mostly. So I would say support your local rock band and support your local hoster. We also have some credits on AWS, which is why we also use them, and maybe also for some other reasons. But anyway, we are pretty flexible in that regard. And then PyTorch as a choice for machine learning experimentation is quite nice because it's simple. If you want to get practical with machine learning in Python, I can only recommend it. It allows you to get something fast, and it can also be optimized quite well and fast. And one of our team's favorite learning resources is basically Fast AI, which also uses PyTorch. So if you want to get into that, then I can only recommend. Now I want to go a bit further, and I said earlier that, okay, we need a lot of data. And thinking about this, we thought about strategies. How do we get our clients, which are basically platforms, so our services B2B2C, how do we get our business clients to provide us enough feedback data? And so far, it's working quite okay, but in the long term, I can imagine that we cannot really integrate that well with all the clients that we support directly. So what we came up with is an idea for a blockchain platform that basically rewards people for providing data by giving tokens, basically. And the idea is for us to get data, but also to let people actually participate in the profit of their valuable participation in the system. So we have a smart contract designed for endorsements, where basically you can put a stake on a provider that you like, so you don't only favorite them, you actually put some tokens on them. And then if others are recommended that service because of that, and then also like them and endorse them and put tokens on them, then you will be rewarded according to that. So that's the basic idea of those endorsements. Then we also have some means for data access control, where clients should be able, as we think, because we value privacy actually. I mean, our service is very data hungry, obviously, but we are actually of the opinion that people should control what they want our service, and not only our service, but maybe also other services on the platform, to be able to use from your data. And you might also request a price for that, because that is generating a profit. So why not actually let the people who provide that data be part of that profit? And that smart contract basically is going to work something like that, but that's not like the final thing. That's just there are some technologies to implement, for example, that re-encryption service that I mentioned there, but I don't really want to go into the details. Just want to say, as opposed to maybe the government task force that we heard yesterday, where astoundingly privacy was not even mentioned in the context, for example, of the Huduma service. And I know that it's an issue with people on Twitter. Kenyans on Twitter are very much concerned about it, and we are also very much concerned about it. So I really hope that we can provide a system that works well, includes people, and preserves privacy. So we are building that, just as a side note, on Eternity blockchain. Great technology. There's no more time to talk more about that, but come to me if you want to learn more about that. And finally, thank you, and look us up.
Do we have any questions?
Maybe not a question, but just a comment. Whenever we speak about AI, the first issue that comes into our mind is trust. It is very interesting that you've been able to develop trust based on a system that we do not trust. Thank you very much.
All right.
Hello, that's pretty cool stuff what you showed. And I'm interested to know whether it's already live with the use cases, because I imagine in a place like Nairobi where trust, runs very low with some service providers, like, for instance, your nannies or fundis, people, artisans who take more than they can chew. So if this is actually working, I'd really be interested in it.
Yes, please come talk to me. It's actually working.
Great.
Anybody else?
My name is Francis, and I work in strategy marketing. Now, when we are writing our strategies to our clients, the biggest thing is price. Would it be early enough for you to tell us how much that would cost? Because I really, really like it.
Yeah, I mean, right now we are integrating our first pilot clients, and we already have our taxi up running. And of course, that stuff is negotiable. So just come talk to us, please, if you're interested.
Any other question?
Not a question, just a comment. That's amazing stuff, guys. I think one of the best that we've seen so far.
Thank you.
Really good.
Thank you.